Hello everyone, today we'll begin our discussion of probability theory with an overview of sample spaces and events. Now in this video, we're going to focus mainly on what we call random experiments. So a random experiment is basically we are doing something like flipping a coin or rolling a die or drawing names out of a hat or something of this nature where we cannot predict the final outcome of the experiment. When we have a random experiment, we have what's known as a sample space for any experiment, and that is basically just the set of all possible outcomes that we're dealing with. So I have two examples here, one coin toss and two coin tosses. So for one coin toss, when we flip a coin, there's only two possible outcomes. It can either be heads or it can be tails. In this case, when we're doing a coin toss, both heads and tails are equally likely, so they both have the same probability of 1/2 or 50%. Keep in mind that for all random experiments, that's not necessarily going to be the case for all random experiments. So we might have a random experiment where the probabilities are 75% and 25%. For instance, if you know that your chances of winning a game of solitaire are 1 in 5, then you have two options, losing or winning. Those aren't equally likely. But in this case of a coin toss, we're dealing with two equally likely options, and we would say n equals 2, so n is what we use to indicate the size of our sample space, and we use s as the abbreviation for the sample space itself. If we look at the scenario of two coin tosses, now we have 4 possible options for different outcomes that we can get. So we can have 2 heads, heads then tails, tails then heads, or both tails. So we would say n equals 4 in this case because we have 4 possible outcomes that we can get from doing 2 coin tosses, basically. Now, one other point to make about this is if we just said that we are looking at the number of heads rather than the overall outcome of both coin tosses, we have 3 possibilities, 0, 1, and 2 for the number of heads. So we would say in this case n equals 3. And note that in this case, we are dealing with 3 outcomes that are not all equally likely. So in the case of 2 coin tosses, all 4 of these outcomes are equally likely. But if we look at the number of heads, 0 and 2 are each just one of our possible outcomes up here, versus 2 of these heads, tails, and tails, heads are 1 head, right? So what it ends up actually being is that this probability is 50% for 1, and then 0 and 2 are both 25% probabilities. When we're dealing with sample spaces, we have something that we call events. Now, events are basically just an outcome or set of outcomes within our sample space. So if we look at the scenario of a single coin toss, we have 4 different events that we can have when we do a single coin toss. So the way that we determine the number of events in a sample space is using this simple formula, 2 to the n. So in this case, n equals 2. We have 2 possible outcomes, so the number of events would be 2 squared, which would be 4. So these are the 4 events that we can have. This first one right here is what we call the impossible event. This is kind of like saying that, well, this is the event that corresponds to no outcome. So this would be like saying we flip a coin and then the coin vanishes into thin air and we don't get heads or tails or anything from it. So this would be the impossible event. Next we have the event of just heads or just tails. So these are These both represent one possible outcome. So events that represent just one possible outcome we refer to as simple events. And then finally, we have this last event, heads or tails. So this basically is just saying we flip a coin and something happens. So we call this the certain event. So the certain event includes all possible outcomes of a sample space, and it's always going to have a 100% probability versus the impossible event is always going to have a 0% probability. If we look at extending this to the scenario of 2 coin tosses, once again we have our impossible event, which would be no outcome. Next, we have our simple events. So each of these events is one outcome. So notice that we are always doing 2 coin tosses. So heads, heads, that's going to be, even though we have 2 different things happening here, we would call that a single outcome because it is the outcome of the total, or the total outcome of both coin tosses. So each one of these events, heads, 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 tails, tails, heads, tails, tails, these would all be simple events, because these all correspond to one outcome. Next, we have events that include 2 outcomes. So this would be like saying we we do 2 coin tosses and we get either heads, heads, or heads, tails. This would be heads, tails, or tails, heads, or tails, heads, tails, tails. We can do this for any of these events. Same thing for this next column. These are all events where we are including 3 out of the 4 possible outcomes. So we're saying that one of these, this is the event that we flip a coin twice and we get one of these 3 outcomes. And then finally over here we have all 4 outcomes in one event, so this would be the certain event. So you'll notice if we count up all of these, we have 16 different events. So this is consistent with our 2 to the n that we use to find the number of events in the sample space. In this case, n equals 4. So 2 to the n, that would be 2 to the 4th, which is 16. Thank you for watching, and as always, I'm happy to help with questions.